Okay, so remember that these are going to be 3 examples from section 5.1 on trig identities, and we're going to use the same directions for all of them. We're going to write each expression in terms of sine and cosine. We're going to simplify so that no quotients are in your answer. And just remember that this is a lot of puzzle, and just look and see. You want to try to figure out things that are either fundamental identities, Pythagorean identities, or negative angle identities. So our first example is 1 minus sine squared theta over 1 plus cotangent squared theta. And the first thing you need to do when you see things squared is see if it is a Pythagorean identity. And remember that these first 3 are not the only ones that I can have. So 1 minus sine squared theta is also equal to cosine squared theta over 1 plus cotangent squared theta. The nice thing about that one is that is just one of my identities. That's cosecant squared theta. Now, I'm trying to write this in terms of sine and cosine, so I've made some progress. However, cosecant squared, I think I can simplify, and it also says so that there are no quotients in my answer. So I need to try to write cosecant squared theta. And if I look, cosecant is the same as 1 over sine. So if I have cosecant squared, then that should be the same as 1 over sine squared. So this is also equivalent to cosine squared theta divided by 1 over sine squared theta. Now, I've gotten an even more complicated fraction, but dividing by 1 over sine squared is the same as multiplying by sine over 1. So really, I'm doing cosine squared theta over 1 times sine squared theta over 1. So I have cosine squared theta, sine squared theta. And if I look at my directions, it says write each expression in terms of sine and cosine. So I've got things in terms of sine and cosine, and simplify so there are no quotients in the answer. Have no quotients in my answer. And then the last thing I would want to do is double check that I can't simplify any of these. And none of my identities talk about sine and cosine being multiplied together. So this would be my simplified answer. My suggestion for the next problem would be to go ahead and write it down. So that problem is going to be secant theta plus cosecant theta times cosine theta minus sine theta. Okay. So what I would do at this point is pause the video, remember your directions up above, write each expression in terms of sine and cosine, so I have a little bit of work to do here, and then I need to simplify so that no quotients are in the answer. So go ahead, pause the video, and see what you can do with this problem. Okay, so secant theta. I can rewrite secant theta as 1 times cosine theta plus cosecant theta is 1 over sine theta. Then these here, cosine theta minus sine theta, I'm not going to do anything with. Now, all I'm going to do is FOIL this. So I'm going to be taking 1 times cosine, 1 over cosine theta times cosine theta. Then 1 over cosine theta times a minus sine theta. So this term is negative. Then positive 1 over sine theta times cosine. So plus 1 over sine theta times cosine theta. And then my last term would be to take 1 over sine times negative sine. So minus 1 over sine theta times negative sine theta. Oops, not negative. We took care of our negative right there. Okay, so now I'm going to just go term by term and simplify. So 1 over cosine theta times cosine theta should just be 1. You're going to have cosine theta over cosine theta, which is just 1. Minus 1 over cosine theta times sine theta. I'm just going to have to do sine theta over cosine theta. Plus here we've got cosine theta over sine theta. Okay. And then we've got sine, 1 over sine theta times positive sine theta, so that's going to be minus 1. So I've got a plus, positive 1 here, and a minus 1. So those are going to cancel. So left I have sine theta over cosine theta plus cosine theta over sine theta. And this says to simplify so that I do not have any quotients in my answer. So sine theta over cosine theta, you should immediately be thinking from your fundamental identities that that is equivalent to tangent theta plus cosine theta over sine theta. Well, that is the reciprocal of the previous one, so that must be the reciprocal of tangent, which is cotangent. Now, I have no quotients, and I have no identities that talk about adding tangent and cotangent together. So this would be my final answer. Okay, the last one we're going to try for today. So again, I would go ahead and write the problem down, pause, and see if you can try this one on your own. So 1 plus tangent squared theta over 1 plus cotangent squared theta. So go ahead, pause, think about some of the hints we've talked about, and see if you can do this problem. Remember, you want everything to start being in terms of sine and cosine, and you want no quotients in your answer. Okay, so I have 1 plus tangent squared theta. As soon as I see anything that is a trig function squared, I want to start seeing if it fits one of my Pythagorean identities. And I just want to caution you to be very careful that all of the signs, meaning positives and negatives, work. So the fact that I have 1 plus tangent squared theta, that is exactly one of my Pythagorean identities. Tangent squared theta plus 1 would be equivalent to that. So that top piece would be secant squared theta. 1 plus cotangent squared theta is actually cosecant squared theta. If you look on your Pythagorean identities, that's the third one. So now I have secant squared theta over cosecant, and I have a couple of goals here. I need to get those in terms of sine and cosine, and I don't want any quotients in my answer. So secant squared is the same as 1 over cosine squared theta. And cosecant, so I'm still dividing, because all I'm doing is replacing cosecant with its equivalent, which would be 1 over sine squared theta. Now I'm dividing two fractions here, so dividing two fractions is the same thing as multiplying by this reciprocal. So I really have 1 over cosine squared theta times sine squared theta over 1. Now I can multiply straight across the top, straight across the bottom, so I have sine squared theta over cosine squared theta. Now, I've accomplished one of my goals, which is to get everything in terms of sine and cosine, but the other piece says that I shouldn't have any quotients in my answer. So sine squared theta over cosine squared, sine over cosine is tangent, so this final answer should be tangent squared theta. Okay, make sure that you are attempting some of your homework problems tonight. You may have to manipulate two sides, so both sides of an equation, to get them to equal each other instead of just one. And we'll keep practicing these types of problems.